Berente from the University of Notre Dame, who kindly agreed to give a talk at our seminar, which was initially planned that Nick would visit Bremen to be there with us, but apparently nobody of us is really there. So thank you also for agreeing to do this virtually. I always like to give a little bit of a story when I introduce speakers, and I recounted like when was my first encounter with Nick, and it wasn't a personal encounter, but I was flying to the Academy of Management meeting in Philadelphia in 2014, and I had a couple of papers, listed to read on the plane, and one of them was Nick's 2012 ISR piece on NASA, and I read it. And it pretty quickly became clear to me that it's one of the template papers for how to write a good qualitative paper or even excellent qualitative papers, because you could really see that what was going on in the NASA case. So the paper essentially is about the NASA trying to implement an enterprise resource planning system and scientists basically playing cat and mouse with NASA with workarounds and everything, and finding ways to use the system sustainably, but in ways that management didn't necessarily foresee. And I could immediately see myself with my own workarounds with the system that my own university had back at that time. So it was very easy to relate to that, what was going on. And it was very tangible to me what was going on in the data. And then some years later, I met Nick at a workshop in Liechtenstein, and we've kept in good contact ever since. So Nick Berente, I would say, is one of the leading scholars in the field of information systems. He's currently editing a special issue on managing AI in the MIS Quarterly. And Nick is also an associate editor for MIS Quarterly and has been an associate editor for information systems research before, and I think won at least one prize as best associate editor in ISR. Where he has also published widely, so his work basically has been published in leading journals in both management and information systems, and even in general interest journals, as some say, such as Nature and Science. So one of the few scholars who, from our field, made it to these very, very reputable outlets. And it's a great pleasure to have you here. Thanks again for coming, and I'm really much looking forward to your talk.
Well, thank you, Laurie. That was a kind introduction. I appreciate it, and I appreciate the invitation. It's an honor to be here virtually and invited to share my thoughts on artificial intelligence and managing AI. Now, you can't see my screen, correct?
We can see it, yes.
There's a beautiful campus there with Grow the Good in Business, right?
Yes.
Okay. All right. So we spoke about the sorts of things you'd like me to discuss about artificial intelligence, and it seems like in its different forms, I've been focusing on artificial intelligence almost primarily for the last year and a half or so, ever since we decided to do that special issue. And then some of my research projects started coming to a head. But my focus on artificial intelligence is in organizations, right? Where I'm trying to understand management and how what do managers need to do when faced with artificial intelligence. And I work with executives, master's students all the way down undergrads in my teaching. And then as far as my research goes, I'm really trying to unpack this. And then, as you mentioned, we have the special issue. So a lot of what I'm going to be talking about is really a reflection. I took this opportunity to reflect on the last year and what did I learn from thinking about how organizations and what did I learn from a research standpoint. So I'm not going to be talking too much about what I do with executives or anything like that. We can do that another time. What I'll be doing is talking about from a research standpoint, and I'll be puzzling through where we are, where I ended up. So that campus you see in the background is the University of Notre Dame, where I currently reside. And just to let you know, where the University of Notre Dame is, we're in Indiana, and that's that green dot there. So if you look at Chicago, which is in Illinois, right in the middle of the country, just over it. Some people even think we're sort of an extended suburb away from Chicago. There's a train that takes us directly between Chicago, and it takes about 2 hours though. So this is a long distance in Germany, a short distance in the US, right? I guess from a standpoint of a nearby city. But we're famous for our football team. It's one of the oldest, most winningest traditions in American football. And then we have the oldest marching band, among other things. But really our tagline is grow the good in business in the Mendoza College of Business where I am. And the thing that I think is beautiful about our tagline and our business school is that it's not just a tagline, but it really runs through our teaching, our research, and a lot of what we do. And the idea is to grow the good in business, which I also very much like, because it implies that business is not evil, right? That it is inherently, it has good attributes. And one of our goals at the Mendoza College of Business is to grow the good, the wonderful parts of business, right? And that's what we're trying to teach leaders of the future to do. So back to artificial intelligence. This, as I had mentioned, was inspired by the MIS Quarterly special issue that I'm running with some other folks, including Jan Recker from the University of Cologne. And we decided that so many of our colleagues in the field of information systems were doing research on artificial intelligence in their various ways that we thought it would be nice to put a stake in the ground and have a special issue. And we announced the special issue, and we accepted submissions 6 months later. So it was a really accelerated time. The idea was not so much that people would start research and submit it to the special issue. It was a matter of, we imagined that they already had research going and that we would assemble a lot of the early research on managing artificial intelligence, with the idea being managing, right? A lot of the work on artificial intelligence is just that. It's work on artificial intelligence. The organizational implications are not necessarily fleshed out in the management implications. And that's what we're going to talk about a little bit today. But before we get into that, let's discuss artificial intelligence. What is it? And this is fun to think about artificial intelligence, because I was at a workshop at the U.S. National Science Foundation, and we had a gentleman who was a computer scientist, and he was a grizzled veteran computer scientist who's clearly been around this stuff forever. And he was talking about artificial intelligence, and he said, well, before I can give you a talk on artificial intelligence, I should define it. And his definition, which to this day is my favorite definition of artificial intelligence, it's whatever we're about to do in computing that we're not doing right now, right? So it's always the next step in computing. We're calling that artificial intelligence. Once we start doing it, we no longer call it artificial intelligence. We then call it what it is, right? And then someone also pointed out to me once that barcode scanners, in the grocery store, that those were really a very early instantiation of computer vision. So we referred to that as artificial intelligence because they could see the barcode. But now, of course, no one would think of barcode scanning as artificial intelligence. So this idea of artificial intelligence is kind of a moving target. And it's really always the next thing that we're going to be doing in computing. And I like thinking about it that way. But, we'll get more specific. Of course, the famous, if you're not aware of where artificial intelligence came from, there was the famous 1956 meeting in Dartmouth where John McCarthy and Marvin Minsky, among others, including Herb Simon and a variety of others, Claude Shannon, as you see here, got together and they decided to discuss it. And their definition is of artificial intelligence, which they coined the term artificial intelligence. They set a lot of the agenda for artificial intelligence, and it was generally making a machine behave in ways that would be called intelligent if a human being were so behaving. That's what they settled on, and I think that's as good as any. As a matter of fact, if you look at the key tome that everybody reads with artificial intelligence, which if you look at their first chapter, the entire book is brilliant, but the first chapter is really brilliant for laying the landscape of artificial intelligence. It's Russell and Norvig, and this is the 2016 version, but of course they wrote the book in 1980. And if you go online, there are PDFs of Russell and Norvig online that you could look at. And the first chapter is really a must read for anybody even thinking about it. And what they did is they organized artificial intelligence in kind of 4 general themes, right? And you can think of the acting as artificial intelligence in the world, right? How we define the thing that we call artificial intelligence. And then thinking, you can almost think about the field and the academic pursuits, right? So artificial intelligence could be really, they subsumed cognitive science into this. So if you think about thinking humanly, they were thinking about research into how humans think. And they thought if we can think, it's really the information processing view of human reasoning. And if we can think about how human beings think, that'll help us to build a machine, right? And then there's acting humanly, right? Which is, all right, let's look at machines that are out there doing things in the world in a certain way, right? Versus thinking rationally. And they thought they made a distinction between humanly and rationally. Humanly is like humans, whereas rationally is better than humans, right? It's the ideal, an optimal way of thinking, right? We humans are fine, but we're a bit flawed. One could imagine a perfectly rational device, unlike us irrational humans, right? So that idea about research into rationality and philosophy of rationality, right? They talk a little bit about that. And then we go on to, developing systems that are more rational than we humans, right? So that's their distinction between the study of these things and then the development of these things. They distinguished thinking and acting, right? And this is how, and of course they, in their book said, well, that's where they want to focus. They want to draw on all the other things, and their idea is to construct rational agents. So these are autonomous algorithms that act, in a sense, more rationally than humans. And if you're interested in what they had to say, you might want to pick up that book. The thing that I've done with this, and granted, it's not consistent with it, and this is what I do actually with my MBAs and with my executives, is I let them think about technologies right now in this slightly, it's the same intuition, but slightly different kind of 2x2. And I have them think through the technologies, clearly based on Russell and Norvig, right? With there are technologies out there, and this is how they want to think through the technologies when they start working through how to use these technologies in their organization, right? And there are technologies that help think like a human, act like a human, which I put in the physical space, and then thinking better than a human and acting. And of course, I look for examples in each. And if you think of thinking like a human, natural language processing, computer vision, and then of course some examples of these things. These are attempts to just approximate. Humans can do it very well. We need to, and what we're doing right now is we're constantly developing systems that can try to approximate how humans do it, right? Similarly with robots and drones and such, we're trying to act in the world with devices that was formerly that, if you look at cobots, right? Those robots that work alongside humans, they're starting to do things that humans could do in the world and in the past couldn't. So machines, but human-like machines, right? And then my format, sorry about this. And my format's not what it should be. Apologies for that, but thinking better than a human, right? You can think of reinforcement learning, unsupervised, right? And here I have an example of procedural tools, right? Procedural generation tools in video games, which is one of the things we study. And they'll do things like generate huge quantities of digital content that is beyond the ability for any particular human to do, or we'd need an army of humans, right? And computers can do those things far more quickly. And then, of course, there's acting better than a human. And that's when you combine the thinking with some activity and probably the primary way we might think about this, or an exemplar of how we might think of acting, but it is an autonomous vehicle, right? Where we're taking a lot of the artificial intelligence tools, we're taking a lot of the action and physical tools, and we're going to create entities, agents, actors that will act autonomously in the world, right? So I actually think of that whole purview as domain for research, right? Everything you see here is a domain for research, and I would happily count it as part of this wave of artificial intelligence that is right now reshaping so much of what we do. So that was the domain. Now, what I'd like to do is, so that's artificial intelligence, what we mean by artificial intelligence. And of course, the tongue-in-cheek view is anything we're doing in computing that we're about to do in computing, right? And then the question is, but of course, any kind of machine learning is how we're using some sort of neural network algorithm is how we're generally conceiving of artificial intelligence. Now, what we found from the special issue is that this broad conceptualization of artificial intelligence is pretty much the conceptualization in the field. We got submissions around robotics. We got submissions around all sorts of things, from chatbots to machine learning algorithms and human resources management, a variety of different areas. And as we were looking at all these submissions, the first thing we, or at least from my standpoint, I don't want to speak for all my co-editors, we realized is that a big thing that a lot of those submissions were doing was essentially recreating what we already know about information systems. Because on one hand, if you think about it, what is artificial intelligence? If it's always the next thing we're going to be doing in computing, then what we know, and they're software based, they involve data. We've been working with technologies that are software based and involve data now for decades. And if you look at it, and these are just some thinkers I pulled out from our field, but certainly the larger than life characters like Herb Simon and Wes Churchman, we found that some of the things people were discussing, Churchman and Simon were writing about and going beyond what they were saying in the 1960s and early 1970s, right? They were discussing, Churchman was discussing, computers and search algorithms and how to manage and how to think about what he called inquiring systems, but he was really talking about a certain type of artificial intelligence technology, even in his caveats about it. And he was coming up with processes around how we can say augment those systems with humans and with other technologies, right? And he was talking about this in 1971, 1968. Herb Simon, of course, talked about using technologies for planning and for design. He, of course, talked about designing them and planning for them, but he went beyond that in Sciences, the Artificials, and in other work of his. And what we realized, and then there are a whole host of others. I have some here that studied artificial intelligence in the early days of information systems. And it seemed like so many of those submissions to our special issue were essentially recreating what we've already done, which was unfortunate. And if you look, and these are any just kind of article blurbs I'll show you. I'm not necessarily recommending any of these articles. I just pulled them, and these are from the old pages of MIS Quarterly. If you look more broadly at our discipline and look at information systems research and the host of other IS journals, you'll find probably a similar pattern. But one of the big things we found is that really, if you look at it in the 1980s, we had a ton of work on expert systems. Things like their liability, things like thinking about how it fits into your strategy and what your expert system strategy is, and that's different than your IT-based strategy. We had an incredibly vibrant discourse around expert systems, and an expert system at the time was artificial intelligence. Right now we have machine learning systems. Then we had these very structured, rule-based systems that we called artificial intelligence, but they were able to do things in a way autonomously that previous technologies had a difficult time doing, right? A lot of configurational type output. And we did a lot of research on that. And I think the good thing about this, the bad thing about this is that I'm recommending people go read some of this stuff. The good thing about it is that, they didn't have all the answers, but they did lay some strong foundations for what we should do. And I think we need to I guess, respect that and realize that so much of what we're doing, so much of what we're thinking about with managing AI actually has already been studied. And as scholars, we can't just act like we're reinventing everything anew. We need to identify what is the difference. What is that partial out? What is it that's different about managing AI? And this is what we try to do with the special issue authors. And the nice thing is we had the special issue, we had an accelerated cycle, and now it looks like we'll be getting about 7 or 8 really wonderful papers out of it. And we had a lot of wonderful papers that didn't quite make it, but it was one of those things where we had this accelerated cycle. And I think those other wonderful papers that did not make it are going to be maybe built up a little bit, and hopefully it'll impact the field with a lot of this thinking. But I would say that's the biggest thing that I learned from this special issue, is that, so much of what we want to do, the questions we have, at least the foundations for them have been established already. We don't have to act like we're creating things anew and from whole cloth. We can actually, there's an actual strong basis upon which we might root some of our knowledge. And then our goal is to understand what that difference is. So let me give you some examples. The way we're thinking about the field in management, right? There are 4 different dimensions that we want to, or domains that we would want to do research around managing and artificial intelligence. Certainly managing the development of AI tools, managing their implementation. So the outcomes, the impacts, understanding what they are, direct and indirect impacts. And then of course, governance, right? How are we going to structure our organizations and processes and practices to govern AI oriented situations, right? And if you'll forgive me, what I'll do is, again, remind you in each of these that there's a strong tradition. And the first is development. When we talk about developing AI, I've seen now a number of papers that are proposing sort of an agile or some sort of life cycle for the development of AI, and don't touch upon the rich tradition of agile in development for other, software-based systems and information systems, right? So again, the IS tradition has a tremendous history, a tremendous tradition of studying IS development. And, if you were to ask a question that was something like, how can I involve non-technical folks in the AI development process, right? What should my practice look like? Maybe your research question is there. I would suggest, well, we go look at participatory approaches in information systems, for example. And there's a lot of research, Scandinavian approaches, again, from the 70s and 80s and 90s on, even pre-Agile, that talk about how non-technical folks can be involved in the software development process. And then what I would do is say, okay, all of the big work is already done for us. Now we just want to understand that little increment about what's different with AI. Okay. Similarly with implementation, there are thousands of papers across a variety of traditions, individual level, organizational level, around implementation and resistance and that sort of thing around information systems, right? And again, the point is, if you're going to talk about how are people resisting AI tools, are people, how to best implement AI tools, maybe a good place would be to start with information systems and understand, how can I get them to actually use it in their decision-making? Well, how can I get them to use any information system, right? Would be the first part. And you might, draw upon some of the abundant work in the field of information systems on decision support, right? And there's a lot about decision support systems and getting folks to use them and how to get executives to use decision support systems. I mean, even if you go back to and there's not much research on this, but in the early days of operations research, there was a lot about trying to get behaviors around modeling. You know, here they were, the operations research tradition was trying to get organizations to use, you know, quantitative models to help make decisions. The problem is the organizations were not using them, right? They were instead preferring to, you know, pick and choose the models that fit their preconceived agendas and that sort of thing. And there was actually a lot of research on this, and you'll see a lot of this happening now with artificial intelligence, right? We find ourselves recreating the past. So that might be the implementation and the outcomes, right? Certainly a lot of what we talk about in information systems research has to do with the impact of technology, right? Maybe on productivity, organizational agility, you know, even things like sustainability and development, emerging development in emerging countries. So there's a lot about how we can impact, how information systems can impact the world and impact businesses. There again, if we want to understand, say, for example, how executives, we might, you know, again, look at executive information. You get the idea. I don't need to belabor this. We could look at the, particularly privacy, right? Privacy is huge with artificial intelligence. How can managers reconcile privacy with fairness? If you go look at this book, Mason, and Coleman, they really dig deeply into issues of privacy. And my version, I think, is the 1990s. And a lot of what we see playing out right now in commentary around privacy with artificial intelligence and the big data and algorithms, they've addressed pretty substantively in that book. So again, what's the conclusion here? Well, there are 4 domains that, you know, general domains of how we want to think about management and management with artificial intelligence. And my argument is that in each of these domains, there's a strong body of knowledge that we can draw upon. I'm not saying AI is not at all different, and I'm going to talk a little bit about how I think it might be different, but we can't act like this is a brand new technology, right? It's a software-based tool that involves data, and we've been studying software-based tools that involve data now for decades, and we have a lot of knowledge. And I showed you some of the stuff about it from the pages of MIS Quarterly, and my point is this, that right now, so far in the presentation, this is what I'm saying, is managing AI is managing information systems plus, okay? And that question mark is up for researchers to answer, right? Which is, all right, we can pretend like it's a brand new thing, but then we're ignoring all the work that's come before, and we're actually making our job much more difficult. But if we look at what has come before, then we'll find that there is something different here. And we have to start really identifying what that difference is and what that means to management, right? So that's what we're looking for, is that little plus. But we don't want to forget managing AI is going to have a lot of similar foundations to managing any other software-based technology. Hopefully that makes sense so far. And then what I'd like to do is get into some things, and this is speculative, right? I haven't quite thought this through. So what I'm going to do is talk about some of my own research at this point, and I'm going to sketch up general directions for what I think might be different. So hopefully that's the sort of thing you were hoping for here today. And I'll get into each of those with an example, right? So the first is development. And this is really the first study, and we published, it's a short little commentary in CACM a couple of years ago. But it's really the thing that got me into this, starting to think about artificial intelligence. And we looked at social bots and online networks with Carolina Salge at the University of Georgia. And we were trying to figure out, how can we determine when the ethics around a bot? So we have these bots and they're doing bad things in, say, online social networks. There are bots that did things like order drugs. There are bots that are making, racist remarks. There are bots that are doing generally bad things. And then the question is, and this is what started us, is who's culpable, right? Who's responsible? Like Microsoft had their Tay bot, which is famous by now. I'm sure many of you have heard of it. But Tay, they put out there on Twitter, and they just thought their Tay bot would learn from people and just be a good, conversant. And what happened is trolls very quickly started playing with Tay. They realized that Tay is learning, and they got Tay to say all sorts of, racist and horrible things like within 24 hours, right? So the question is, who's responsible, right? When bots do bad things, who is responsible? And that question, we put together a little, ethical decision criteria, which you see here. But more importantly, is it got me thinking that there is something different here than other information technologies. And that's that there is some agency and some unforeseen agency that the developers and the organizations that put these bots out are delegating to the, so you have the autonomy, you have the agency, and this is a delegated form of agency. So the question is, when are the organizations culpable? And our conclusion in this paper is that, well, they're culpable when they're culpably ignorant, right? Since this is an emerging domain, they should take it upon themselves to understand what other organizations are doing, what best practices are, and being on top of it. And if you find that they're not on top of best practices, they're not testing their algorithms in this really, then they do have culpability, right? And then they need to, and then we gave the required, they should, apologize, immediately revert, and accept responsibility. Well, that was the point there. That little article got me going, but it made me realize that there is something different here. It's not a typical information system. Because of its autonomy, because of its learning character. And what does this mean to managers? Well, it means that managers need to think about things they didn't think about before, right? They need to understand. In the past, if we didn't follow good software development practice, fine, well, maybe we just didn't develop things quite as well or as fast or as effectively as other folks did. There was something managers may, if they wanted to, just delegate to the folks who work for them. When it comes to algorithms that are out there working on your behalf, it changes. Now managers need to understand the best practice, understand it from a liability standpoint, right? That there is real organizational liability that comes with deploying autonomous agents that they can no longer protect themselves from in the way that they used to, right? So there is something different here, and it has to do with the delegated agency and the culpability of those technologies that you put out into the world, right? So that's one point of distinction that we in the development, and I think that that's super important for the sense that, we look at things like privacy, which I'll talk about in a minute, but in the past, managers could delegate what a lot of the technical issues, a lot of the software-based issues to their technical staff. And I think what we're seeing with artificial intelligence is that a lot of the issues such as software development methodology and testing methodology, which was very much in the purview of the software team, is rising up to the level of even the legal team in an organization and other managers in an organization. So that's one study on privacy, but then on development and ethics and culpability risk. But then, and this is something I'm doing right now, and we're writing it up with Karina Rushi, who's a PhD student from the University of Bern, in collaboration with a company that does chatbots and robotic process automation. But what we're realizing is that when you develop these bots, these artificial intelligent tools, RPA, robotic process automation applications. You can't take the same perspective for all of the applications, even within the same application, right? We might have something like a help desk, but the help desk might have something like small talk in it, and it might have frequently asked questions, right? We have some autonomous agents doing this, and we realize that the different components of an application will have different training needs and different privacy, data privacy requirements. So now we're running into a situation where this very modular view of what is AI. We don't think in terms of a broad application. We have to think in terms of its components. And we have to take those components of each, total application. We might call it a system, and we take each component and call it an application. And each application, each AI application, we need to treat much differently based on the sensitivity of the data, the training data, right? And the specificity of the model itself. There are different models we can bring to bear. And some data sensitive, some data is not. The models are very specific to our organization, or they're very generic, and any organization can have them. And depending on what we're doing, it could be a generic application, right? Which has, anyone can use, and it's fine, it's open, we'll share our data. But even then, even when we have open data, there are issues around privacy that, where people can take open, innocuous data and triangulate around it and do all sorts of potentially identifying. You can take de-identified data, for example, and do some interesting things and start identifying it, right? But then there are ways to make your data generic, right? And there's basically an entire kind of sub-discourse on differential privacy and on other issues around how can I take my data, make it useful for machine learning, yet at the same time protect the vulnerable or protect anyone from wrongdoing. And just the privacy around sensitive data, thinking through technical issues of specificity and what can be shared, decomposing this is no longer something that only technical people and only information technology folks can do. This is, again, legal, marketing, managers throughout the organization need to understand these issues around the different application components of an artificial intelligence system and how they're going to strategically govern and make sense of, say, training their models, right? Managers can no longer delegate this, right? It's not something that, in the past, privacy was almost linked to security. We had this idea of perimeter security. If we could just keep security to, keep security down, that's how we handled privacy, or a lot of our data privacy issues, right? That's no longer the case. And managers of all sorts, not just technical managers, need to start understanding and thinking about privacy. Then I'll move on to implementation. This is after you're implementing autonomous technologies. And we looked at, in a series of papers with Stefan Seidel and a host of others, on Ubisoft and video game design. And they're using a lot of autonomous tools, a lot of artificial intelligence tools, particularly procedural generation for the development of video games. And we're finding that, there's actually, it's this idea of augmentation, which has been around since the beginning of artificial intelligence, where, we have systems out there, they're not going to do everything. We need humans to augment them. So similarly, we're using these really next generation technologies to develop our video games and to do really interesting things that humans can't. So our question is, all right, what do managers do? And what we found is, well, if you look at the design process, it historically, and this is RGRS's famous double loop learning, right? Which is that there's what you're doing and it has a result. And you learn about that. You have a mental model of the process, and that impacts what you're doing, which is the result, right? This is how designers act. This is the double loop learning. You learn from your result, you design from where you learn from your result, and then you think about the situation and then you do your design. When you incorporate autonomous tools into this design process, what we found is that the role of the designer becomes different, right? And the role of the designer their reflective practices become different. They need to understand the model as much or more. It becomes far more complicated because they start working the model, right? They need to understand the mental model of the algorithm. Again, transparency, interpretability, explainability, that all comes in here. But the role of the individuals in their augmentation is fundamentally different than it was before we had autonomous tools. And in this particular work, and in the first of these, right, the way that we're characterizing that difference is that in the past, with you use the tool to do what you were doing, reflected on the process, reflected on the feedback from what you were doing. Now you still need to do that, but you also need to think through an entire other loop of learning where you're trying to understand, you're trying to reconstruct the mental model of the autonomous tool. And then we find them gaming the mental model of the tool. We find them doing all sorts of interesting things. So that's another place, this kind of where humans augment. And then another area where we're seeing a bit of a difference, and my postdoc advisor, John King at the University of Michigan, always said that, you know, things are just a difference of degree, but when things get to be such a difference of degree, at a certain point, they become a difference in kind. And we see that with things like, and this is a study I started with Hani Safadi at the University of Georgia and John Lawler at Notre Dame, where we're looking at bots and social networks like Reddit and that sort of thing. And this is a Reddit community bot. And what we're finding is, what do bots do? Well, bots do the exact same thing that humans do in these communities. They post stuff, they respond to stuff, and then there are these governance bots that go and clean things up and do all that. But humans do that too, right? But what happens is they're doing it so much faster and so much more frequently that this difference in degree becomes a difference in kind, where the inclusion of bots on a network has tremendous impact on things like information exchange in the network, sociality among non-bots in the network, as well as the breadth and the depth of human-to-human interaction. So what we're seeing, and again, we're just writing this up right now. So this is what we're toying around with right now, and that's that when you introduce a bot, human interaction with other humans changes than if you were to have introduced a similar human. So we're playing around with it. There's not a lot there, but it has to do with the same thing humans do, which is post stuff, organize stuff. But the speed and the amount that they do it impacts dramatically. Now, there is this other element, which is that people do perceive them as non-human. Typically, most bots don't go off fooling anybody. You know, most people do perceive bots. So there is this issue of people do perceive agency of some sort as a different sort of agency than a human, which also matters. But anyway, that's one thing. And then the final story I'll kind of tell you about is, and we're working on this. It has to do with governance, and it has to do with governance of artificial intelligence. And I'm doing this with my colleagues here at University of Notre Dame, where we're trying to go back to some of those early folks that I started my presentation with, like Churchman, like Simon. Simon has his idea of designing without end goals, right? When we have these artificially intelligent learning algorithms, they're way better than we are, say, you know, reinforcement learning, if we give it a specified goal. We give something a specified goal, good quantitative data to work with, it's going to be better than a human at solving the problem. However, that's not what we're doing in organizations. We're always moving, you know, we have multiple stakeholders, multiple goals. We have to make these trade-offs. It gets really complicated. And Simon had this process in his chapter 6 of Science is the Artificial, where he talks about design without end goals, where we don't have end goals. We're always just designing for this multiplicity. And we think that there's something there about a governance, a socio-technical governance approach. You know, of course, using Simon's procedural rationality as the thread, but it's creating a context without end goals. And then from Churchman, we're borrowing his idea of the inquiring system, right? Where he had a technical, and you can think in terms of adversarial learning or something, where we have technical components that question stabilized and possibly flawed algorithms in situations that are using artificial intelligence, right? But that's what we're doing, and I guess we're playing with it. And to me, there's this idea of a procedural augmentation, right? We think that humans in the loop. We think that humans will somehow be the guarantor of that artificial intelligence doesn't go off the rails and do bad things. But humans are actually really awful guarantors of this. And the reason being, they have all these biases. In order to set up things, they have to make all these judgments. And there are tremendous limitations to any technical solutions for goal multiplicity. And we show that in our paper, in the sense that, yeah, we can adjust for one definition of fairness, and we can do that quite well. The moment now we have to do a trade-off between fairness and accuracy, we run into all sorts of problems. And then, of course, in the real world, it's not just a question of one definition of fairness and accuracy. It becomes dozens of potential goals that are all conflicting, and there's no technical solution for that, right? So there's a process, a procedural framework that we're trying to develop for governance. And we think that this procedural framework is substantively different than many of the governance structures that we've come up with in the past within organizations. So with all that said, right, these are the domains. Managing AI. What is managing AI? It's managing AIS plus. And then some of the areas that I think are really fruitful for the plus is around augmentation, human and organizational augmentation of artificial intelligence. I think it's around privacy and ethics. If you've noticed, artificial intelligence has rekindled a lot of discussion around ethics where, 5 years ago, you probably didn't hear that much about ethics other than perhaps sustainability in organizations, right? Maybe social justice to some extent. Now with artificial intelligence, and of course in recent years, social justice here in the US and I guess in Europe has, in this year, has taken a bit of a foreground again. But also around artificial intelligence, we see a whole blossoming of research on ethics, and yeah, augmented governance, privacy, ethics. I think there are a lot of domains that are different, and I think it's our job to figure out what that question mark is and extend previous work. Thank you.
Okay. Thank you very much, Nick. That was an excellent talk. I thought it very nicely led into the issues that arise when we approach AI from a more managerial perspective. So thank you very much. And I actually agree completely that it is very important that we don't forget all the concepts that have been laid out over several decades, and that could actually explain some parts of what we're currently witnessing with AI. I thought that was a very nice take on it. So thank you very much. Now I'd like to open the virtual floor for questions to Nick. So either just raise your hand or post them in the Q&A section. And we have 2 questions already lined up. So the first one goes a bit into your matrix, I guess. It asks, so supervised learning usually draws upon data that is shaped by human behavior and thinking. How can it be used to create machines that think better than humans?
Yeah, so did I have supervised learning in the better than humans side? Well, I think supervised learning is usually what we do with natural language, with computer vision. So I understand that. So I think I had it, I play around with that. That's totally for play. I guess you can think of it 2 different ways. One is if we're talking about the actual learning, then yes, maybe we should put supervised learning over with computer vision and natural language processing. But if we're talking about, once we've trained right? We've used the tool to supervise an algorithm, and it has learned, right? A trained algorithm can outperform humans in certain specific tasks, right? So again, don't take that 2x2 too seriously. That's something I do to play around with when I'm teaching, right? That's not something I'm putting forward as, I just thought when we were establishing the domain, I wanted to establish that I meant kind of this broad domain, and I'm playing around with those ideas. This is nothing I've written up or even planned to, but yeah, I think whoever chatted that is probably right, that we need to, if I were to think through this very carefully, I would probably put supervised up in the natural language processing and the computer vision space, right? Because that's how we get it to act more like a human.
All right, excellent. We have another question in the chat that goes a little bit more into the broad managerial picture, and it asks, how will AI governance mechanisms change from previously known technology governance mechanisms?
Well, I think, so when you say governance mechanisms, man, that could be a lot of things. So let's just talk about organizational structure as one potential governance mechanism. And we've done a little bit of work on this. I mean, Lori, from your own work, you'll know that a lot of organizations are doing digital transformations, and they're finding that these digital transformations are not simply relegated to, say, the technical function anymore. So a lot of them are spinning off these separate organizations. They're calling it the digital unit or digital innovation unit or something else, right? Where they're spinning it off into a different unit. And some organizations have the digital, like if they're making mobile apps or something, they'll have the marketing group doing their own mobile app, and the IT group no longer does it, right? So what we're finding in organizations, in traditional organizations, is that the common understanding, the very fundamental intuition of governance, which is we need our strategy, then we need to align our technical strategy with our organizational strategy, and then we need good governance mechanisms to support and structure that technical strategy. What we're finding is that is totally flipping on its head. And it's no longer this idea that we need to govern technical activity in order to support what happens when the technical activity is the real business, right? And that's what we're seeing with like Lori's work with digital transformations, right? When we're making digital everywhere, now it's about organizational governance. It's no longer about technical governance, right? So what we're seeing with artificial intelligence is, so the general intuition, I'll start with that and then I'll give you one specific example. So the general intuition is we have AI, let's say at some future point, everywhere. It's no longer a matter of we need to govern our AI in such a way. It becomes a matter of our organizational governance needs to account for AI, right? There's not going to be some separate artificial intelligence governance, right? So for example, we're going to have AI in our products. We need all our product governance, product lifecycle management have to accommodate artificial intelligence. Similarly with internal. And I'll give you one perfect example of this, and it's at banks right now. And I would say the number one place that artificial intelligence is finding its way, the very first little foothold that AI gets in large established organizations, is through robotic process automation and chatbots, right? And I was talking to a large bank, and they had something like 500,000 RPA bots running around the organization doing various things for compliance and that sort of thing. It was a very large bank. And if you think about it, these are supposed to be little scripts, right? No one's really excited about RPA. RPA is this little script that goes between your real systems, right? But now when you have thousands and thousands of these little scripts running around doing super important things around regulation, interacting with customers, interacting with employees, all of a sudden these little scripts that were like the side thing are now becoming the center. They're becoming the way that we execute our organization, particularly once we start our organizational processes, particularly once we start implementing things like computer vision, better natural language processing. We use chatbots to interface with more of an audience. All of a sudden, that becomes governance of essentially RPA bots and chatbots becomes our technical governance and our infrastructural governance. And the big monolithic systems we end up encapsulating and servitizing and having them just serve the array of kind of no-code chatbots that are running around our organization. So that's a long answer to governance mechanisms, but I think we need to rethink governance, and it's no longer technical governance versus organizational governance. It's all organizational governance, and we need to bring the technical elements into our organizational governance practices.
Okay. Excellent. Thank you very much. We have one question now that is where I see a hand raised. So Corinna, I'm giving you the allowance to speak, and you may state your question right now.
Hi, do you hear me?
Yes.
Great. Hi, this is Corinna Rucci from Bern.
Hi.
So thanks a lot for your talk, Nick. This was super interesting. I really liked your introduction of the definition of AI in the beginning. So that you say basically, or the definition you refer to, that this person said that we don't really know what AI is, but we give it a name once we understand or developed or whatever. So as an example, once we had machine learning, we called it machine learning and no longer AI maybe. So I was wondering, do we even need a definition of AI then?
Yeah, and my answer is, well, all right, so there are two different answers to this. The first is not from our standpoint doing research, right? We should probably just call it, machine learning and that sort of thing. So, or whatever it is, the topic that we're looking at. So I think we as researchers probably don't need to use the term AI. However, the reason it works is because people are so excited about it. So as a signifier that we're doing something really cool in next generation, and as a signal in order to get resources, in order to get people reading our work, I think it's a great, for people who formerly were not technical. I think everybody's got to start getting technical, at least on a high level. But people who in the past did not consider themselves a technical person are not going to be excited to hear about management of machine learning, right? But they will be. So as a signifier, I think it's important. The substantive definition of AI, I think, doesn't matter so much. I like the definition of whatever we're about to do in computing. But as a signifier, particularly to those people outside of information systems or technical traditions, I think it's still very important, right? So that would be my answer there. Thanks, Karina.
Thank you.
Excellent. Thanks. So we have two more questions on the chat that both are, I guess, one is more empirical, the other more conceptual. So the more conceptual question first would be, which foundational theories do you think will be applied in AI research, in particular to examine the question mark, the managing IS plus question mark?
Well, the one that I see right now that's probably the top, if I had to say which foundational theory, it's behavioral psychology. And I think behavioral psychology primarily because, so Kahneman and Tversky and that whole behavioral economics. I'm sorry, I said behavioral psychology. I meant behavioral economics. And it's because of the, I guess, the particular, there's a discrete number of lessons around it, and people are familiar with that body. So at least here in the States, what I see is a big kind of behavioral hook into this is in behavioral economics. But there are others. Lately, I've been starting to see more and more social network foundations. And I think a lot of why I'm seeing these is because there are well-established methods, right? But behavioral econ is going to be experimental, and a lot of folks who are maybe of a technical bent are very comfortable with experiments. Social network type work, there's a lot of social network data out there, and it's a nice way to be able to. So I think what we're seeing, the conceptual foundations, are less from a, hey, I want to get at this from a managerial or an organizational standpoint. It's more of, okay, what data can I get and what can I do? So that's what I see happening now. I do think that once we get into organizations, which I haven't seen a lot of intra-organizational work. My own work, it seems we're taking a learning and a knowledge-based approach, right? So we're looking at things around organizational learning, around organizational routines, right? Which really routines are in part the embodiment of organizational learning, and knowledge-based processes, right? So in some of my work inside of organizations, that's the angle we're taking. But I think what you'll find in general is they go where the data is, and a lot of data is online right now. So you end up getting a lot of social network and that sort of thing. Broad-based econometric studies, which don't necessarily draw on theory as much as organizational research traditionally has. So.
Do you see there's a recent discussion around routine dynamics. There was the special issue in Science, I think, where you also had a paper. Now there is the Oxford Handbook on Routine Dynamics. Do you see that as a organization theory concept that may be conducive to bringing in more AI? I think they have a chapter on algorithms and routine dynamics in the handbook.
Absolutely. Yeah, I think that's a wonderful place. Yeah. I could think of that's the first place when you look inside of organizations. I think what you'll see is a lot of psychological stuff, right? Mm-hmm. Initially, where I would like to see something in organizational routines that's really hard data to get, right? Mm-hmm. And then you want to set up situations like field experiments or implementation studies, right, on routines. So I think conceptually what you're thinking, and if you can get that data, Lori, let's do it. But conceptually, I think that's clearly the space where you're going to see big changes in organizations are around the routines. That's also going to be the really hard data to get. Whereas things like individual level around individuals' perceptions of situations, right? Things like that, those will be easier data to get. So we're probably going to see more research in that space.
Okay, so the final question on the chat is a little bit in the spirit of classical Frey and Osterloh paper, which predicted that AI will substitute a lot of knowledge jobs. And the question says, organizations increasingly rely on AI to develop new products. And how do you think that this will affect the relevant skills that workers in research and development will have to bring to the table in the future?
Well, that's a big question. I wonder if it'll actually, so when you think about technical skills, I'm not sure it's really that much of an extra load, right? I think they're different than they were in the past. So the students coming out doing this sort of thing are doing different things than they did. But that doesn't mean that the actual, engineers that are developing these tools and systems, right? They're learning different things, but, I'm not sure, I guess I don't know to what extent that's really fundamentally different. Is it just the next step in the continuum of ever learning new technologies, right? If you look at the whole history of our field of technology, it's that there are always new technologies, and engineers always need to understand the new technology and innovate around it, right? So I'm not sure how that's going to be different, but I will tell you the set of knowledge and the set of skills that is different, and that's around managers, right? And managers in the past, people who come out and lead organizations, were able to delegate anything technical to the people in their basement. So again, I've mentioned this before. They're the tech guys in the basement. This is my real organization. You tech guys, take care of the technical infrastructure for it. I don't think they can do that anymore. I think managers, formerly non-technical people, need to, I'm not saying they need to code. I think that's a little bit of a stretch, but they need to not be afraid of these concepts. They need to understand these concepts. They need to understand what artificial intelligence is, at least intuitively, how to train artificial intelligence with tricks around data benefits to sharing data, right? They need to understand some of these things that they've never thought about before in their lives. I'll give you just one little story. My friend is a partner at a law firm, and he was telling me that, 3 years ago or so, he might have told me this a year ago, so maybe it was 4 years ago. It's like 4 years ago, our business, no one talked to us about privacy. Now he said, we don't have a single client that isn't talking to us about privacy and data privacy. I was talking to one of the big consulting firms and their cybersecurity unit, and it's cybersecurity and privacy now. He said, we put out our cybersecurity unit. We always did security. And now the bulk of our business is around privacy, right? It's around data governance. It's around, right? And I imagine in Europe, and this is in the US, I imagine in Europe with GDPR, it's probably 10 times more intense. But I think this notion of privacy and data, and you can't think about privacy without understanding your data. This notion you can't just relegate to technical folks like you could maybe security issues. So yeah, I think the big knowledge that has to be built is all across the organization around these issues that AI make important.
Yeah. Okay. Excellent. I have one final small conceptual question, because sometimes there is the differentiation between weak and strong AI, which was something that I think you showed it with the different components that may lead to different demands that managers have to have in hand, and that we need to look at AI applications in terms of their components. Does this link with the strong weak AI debate, or would you say that depending on whether we look at strong or weak AI, our question mark, like managing IS plus question mark, may occur in different shapes?
I think the only thing we as researchers, unless we want to be speculative futurists and write bestsellers or science fiction novels, right? We're only talking about narrow AI, right? Narrow AI, right? That's it. Right now we can stack on a bunch of narrow AI applications, right? Sure. And then it can start looking really complicated, like an autonomous vehicle, and start giving us the impression that it's doing really interesting things. But no, it's all narrow. Yeah. Anything that we need to worry about as far as and then as far as the strong AI of the future, it'll come and we'll, I'm sure, address it then, but I don't know when, and I'm the wrong person to be bringing up these to make these predictions. The only thing I generally say is whenever I make a prediction, I'm usually wrong. So whatever I would say, you could bet exactly against that. But yeah, I think all our AI is narrow AI, and that's what we're talking about. When we talk about AI, right now we're talking about very specifically machine learning using neural nets. It's either supervised, unsupervised, or reinforcement. And that's all goal. Singular, limited goals. Yeah.
Okay. Excellent. I guess these are very great words to end your talk and the discussion. So Nick, thank you again very much for giving this talk. I thought it was very inspiring and interesting to see this take on how AI advances our thinking about managing IS. So thanks again for coming. It was really, really cool.
Thanks, Laurie, and thank you for inviting me. Thanks, everyone.